you have got a point P that will travel along this curve that's between -1 to 1 only. They now define, let's let the gradient of the curve at a particular point be called M. So we first need to understand what is M. M is gradient. What is gradient of a curve? Gradient is referring to dy dx. That is gradient. They tell us the x coordinate of my point P is increasing at 9 units per second. And that is when x is half. When I read this number, I will tell myself this is a condition. When do we use conditions like this? I should aim to substitute last, not at the first instance. After you have differentiated, then we try to put in half. What do we want to find? Find the exact rate of change of m at that instant. So can we write down what I want to find first? I want to find dm dt. Okay, but a little bit complicated because m is actually dy dx. Okay, so that's the complicated part. M is actually dy dx. Okay, what am I given? X coordinate is changing at 9 units per second. So x coordinate changing means dx dt. This is 9. Do I need to put a minus? The word in the question is increasing. So increasing is positive. If it's decreasing, we put a negative. So let's form chain rule last. If I want to find dm dt, let's perform a split. The last variable I have is dx. Again, with this planned out, what do we need to do from this? I will then need to form an equation that is between your m and x. If we plan through slowly. Okay, so let's think. M is dy dx. If you had done dy dx, actually you would get m to be between m and x already. Okay, so let's start with the equation. My y is x sine inverse x. It's a product of two terms, so you have to be very careful when you try to apply product rule. Let's go for dy dx. Product rule, be very careful. I put in different colors for you to see. Let's keep x, we differentiate sine inverse. Sine inverse, if you have forgotten, let me just fill in here. It's the one with a square root. Available in the formula list, so no need to worry. Plus, I keep my sine inverse x. Differentiate x will give me 1. Okay, so not much we can simplify, except we can just try to combine together. Okay, what is dy dx? dy dx is m. You need to remember that m is defined to be dy dx. What do you need? This is where it gets slightly complicated. I need dm dx. I already have an equation between m and x, so it's requiring you to differentiate second time. When we plan for our chain rule, I need a dm dx. I only have m and x. So we need to differentiate a second time. The left-hand side here is a fraction. We will apply quotient rule. Okay, quotient rule differentiates the top first. So I differentiate x, I get 1. Multiply to your denominator. Minus. Differentiate bottom will be a bit confusing. Power bring down. Power minus 1. differentiate within the bracket, I get a negative 2x. This is only differentiating the bottom. Must remember to keep the top. So there's another x. Okay, over denominator square. Okay, complicated looking, but I still need to differentiate the sine inverse. So can we get another differentiation on that sine inverse? To make it easier later on, can we try not to have a negative power to appear? So how do we eliminate the negative power? Can I multiply denominator and top by this term? Okay, the idea is I want to eliminate the negative half power. So I put in red here so that you can see. Okay, let's multiply by this term to the top and bottom. We try to eliminate that term. Okay, a few things that will happen. Let's start from the left term. This is already a power half. I combine with another power half, I will get a 1 minus x squared. Certain terms on the right there actually cancels out. There's a negative 2. It will cancel with the negative half outside. So I will end up with a plus. Okay, so there is this x and another x that appears. We will end up with a plus x squared. Okay, the negative half power and the positive half power will be cancelled out. So in my denominator here, I will now be left with 1 minus x squared power 3 over 2. It was power 1 here, and we added with the half. It becomes a 3 over 2. Okay, second term on the right, square root is currently power half. And I would like to force both terms to combine together. So can I make them the same denominator by doing the following? I want to combine the right-hand side term to the same denominator. So it's lacking a power 1. Some cancellations on the left, there's a negative x squared, there is a positive x squared, both will cancel out. So I'm left with 1. Denominator, the whole thing becomes power 3 over 2. And I continue to add another 1 minus x squared. Okay, let's now finish up with the chain rule. So I want to go for dm dt. We write in the chain rule first, dm dx times dx dt. Okay, what are the values that we are going to use? We haven't used the x is half and dx dt is 9. So we're going to sub in both together. Write in this notation at x is half. So we can come back to use our equation. Let's substitute x to be half. Okay, they want exact value, so let's evaluate the numbers slowly. If you have a power 3 over 2, what's the best way to evaluate in exact numbers? For powers of 3 over 2, let's split up into a power 1 times the square root. Okay, that will be the easiest for you to combine. These numbers can all be evaluated together. Okay, so I'm going to press the calculator in one shot, okay, to evaluate all these yellow color terms, and you will get a 21. And denominator, let's change it. Let's write as a root 3 over 2. Okay, so we can combine the numbers. I will get a 42 over root 3. And to make it even more exact, let's multiply by root 3 over root 3 to rationalize the terms. This is about gradient. So what are the units for the gradient? In this question, they did say x coordinate moving at 9 units per second. It's written as units, not in cm or anything. So we will have the same thing here. This will be in units per second.